So the biggest enhancement we did is we added the 8+24 CSAA mode. So instead of having 16 samples for 8 full, 8 virtual, we now have 32 samples, 8 real and 24 coverage. The other thing we did, which showed a big image quality improvement, is we actually allowed these 32 samples to be used during the alpha to coverage operation. So for instance, if you had an 8+8 mode on a GT200, and you painted this transparent disc, as it gets more and more transparent, you'd see these 8 levels of banding. Well, with GF100, since we've got this 32x CSAA mode, we actually use both the 8 real bits and the 24 virtual bits during the alpha coverage operation. You end up with 32 levels. There's still some banding, but it's much, much less. And we've also done a few things to actually improve TMAA, which is a multi-sample AA and TSAA mode beyond this we've got here.
Just a quick interrupt. You heard Emmett say virtual samples and coverage samples. They're the same thing. We tend to call them coverage samples just for better understanding.
Yeah.
Those are B's and C's.
So yeah, the coverage sample. Okay, so next slide. So here's a little excerpt of the age of Conan scene before of the grass. And this is on GT200 in 16x CSAA mode. You can see there's all this noisiness in the grass blades. This is from 2 reasons. One of which is we only use 8 virtual samples when doing the alpha to coverage, so there's only 9 levels of transparency. To get around that banding issue, we actually do dithering, which is what you see here. So even though we're in 16x CSAA mode, we're only using 8 bits when we do the alpha to coverage, or 8 coverage values. Next slide. So this is what it looks like on GF100 with 32x CSAA. Now, we're using all 24 bits, or all 32 bits, you get 33 levels of transparency from fully invisible to fully opaque. And as you can see, the edges here are not only not dithered anymore, they're very smooth. You can barely see any banding at all. Any questions on that?
So one of the things that developers do a great deal, as you know, particularly for any kind of outdoor game, is vegetation. And anti-aliasing for transparent geometry is this alpha coverage or transparency multi-sampling. It is a really important thing. This is a huge advance. It's essentially a 4x increase. Actually, it's probably more than that because of the way that the algorithms resolve. Increase in image quality for transparent geometry. So for vegetation and fences and stuff like that, this is a huge advance. And this is one of the things that developers use extensively, and they're super excited about because no one really wants their jungle scenes to have creepy, crawly, shimmery, vegetation. They want it to look good, and this is a really big advance.
And for better or worse, this is, in today's GPUs, they can't handle geometric realism, and so this is the tricks that they have to do. We wanted to do something to help that as well, right? Not just wait until people can adopt the X11, but also do something to help sort of the kind of quote-unquote geometric realism you see in games today, make that look as good as it can, and this was an investment in that direction.
And even with the increases in our performance and tessellation, doing large outdoor scenes with lots of foliage will still become geometry limited if you actually render everything with polygons. So there'll be a certain threshold where you'll switch from polygon rendering to doing these alpha to coverage type tricks. And what will happen is it'll either get pushed out further in games, or games will just add a lot more foliage to make the scene look denser. Okay. So there's one other area that we looked at and we improved things. We have this mode called transparency multi-sample AA, and it's been around since 7800. Basically, it automatically takes what the developer has set up as alpha-tested geometry, or alpha-tested pixels, and turn them into alpha to coverage. In DirectX 10 and beyond, the developer can actually do that explicitly, but there are still apps that use alpha test instead of alpha to coverage. And you end up with this problem, which is shown in this fence here. And what we've done is improve the image quality of the fence. Let's go to the next slide. Okay. So as you can see, this fence kind of looks sharp, but there's pieces missing. There's bars that just kind of disappear. And so while this picture looks, this fence looks pretty high contrast, the problem is it scintillates all over the place. As you move the scene, some bars will disappear, other bars will come in, things will crawl up and down, and it looks really horrible. So on the other mode that we had on, it's from 7800 on, is called CSAA, which is super sample anti-aliasing. So in this case, you take a performance hit, but you actually, instead of sampling the pixel once, you're generating this alpha coverage value and generating transparency based on that. It would actually sample the pixel at sample the texture at every single sample point separately, and do the alpha test separately, and either turn on the pixel or not turn on the pixel. It helped out these things here, but it was a huge performance hit. what we figured out is how to actually do that in TMAA mode so you don't get the performance hit, and you actually get better image quality than TSAA. Next slide. So here's what you end up with. You end up with a fence that looks a little dimmer, but that's because these bars are pretty thin, so they're spread over a couple of pixels, but they're never really opaque. And also, as you move, the fence moves smoothly. It doesn't scintillate like it used to. That's the other. Any questions? Okay. So one other thing I want to talk about on CSAA was performance. We want to make sure that as you turn on these modes, they're still usable, still playable, and so forth. So looking across an average of a bunch of apps, as we did our benchmarking, we looked at how GF100 and 8xAA performed versus GF100 with 32x CSAA. And your mileage may vary, but on average, it's about a 7% performance hit. What this basically says is GF100 32x CSAA is usually faster than GT2X85 at 4xAA. So you could actually argue get an 8x image quality improvement for about the same frame rate or better.